Good afternoon, everybody. Welcome to our second webinar. We have a couple more minutes before 1, so we're just gonna wait to allow as many people to join as possible. Okay, let's get going here. Well, good afternoon, everybody, and thank you so much for coming to ECOH's second webinar in our 3-part series on radon. Today, we are going to be discussing radon regulations and your responsibilities. Before we dive into our webinar, I just wanted to touch on a couple of housekeeping items. So today's webinar will be recorded. We're looking to try and get that up onto our YouTube channel. So stay tuned for that in the next few weeks. All attendees will be muted for the duration of the webinar, but there will be an opportunity to verbally ask questions at the end of our overall presentation. So to do that, please feel free to raise your hand, which is in the bottom border here of Zoom, and we'll be more than happy to unmute you. There is also the Q&A panel. So again, if you look at the bottom bar of Zoom, you'll see Q&A. Open that up and feel free to ask any questions in there. And there'll be an opportunity to have those answered by our expert, Bruce, at the end. If you are choosing to join the webinar as an anonymous participant, absolutely no worries. But if we do not get to all of your questions and you would like your question answered, please feel free to follow up with Bruce. His contact details are on several slides throughout the webinar. If you do run into any technical difficulties during this webinar, normally logging in and out of Zoom and then, logging out and then coming back into Zoom will resolve any of those issues. If the issue persists, please feel free to put a problem in the Q&A or email learning@ecoh.ca, and we'll do our best to help you out. And lastly, we would really appreciate 3 minutes of your time at the end of the webinar to fill out a survey. The link will pop up on your screen at the end of the webinar. We really value your feedback, and thank you to everybody who contributed last time. We have already implemented some of those suggestions. So just a little bit about ECOH here. ECOH has been serving our clients for nearly 25 years. ECOH is an acronym for Environmental Consulting and Occupational Health. We were founded here in 2000. We have an office here in Mississauga and also one in Ottawa, but we serve our clients all across Canada. With more than 75 employees and a lot of professional accreditations and experience between us, we are proud to serve our clients in a variety of sectors. We have 3 main areas of expertise. We have teams of experts, technicians, project managers operating in a wide variety of specialties. Our environmental team performs phase 1 and 2 environmental site assessments, excess soil management, and much more. Our hazardous materials department is busy performing assessment for asbestos and lead, PCBs, lots of other hazardous materials. And our occupational health and safety team, which is led by our expert Bruce here today, is dedicated to helping our clients protect their people and property from water damage, mold and bacteria, indoor air quality concerns, and last and most relevant to today, radon investigations and mitigation. So we will be covering a variety of topics today. Bruce will give us a little bit of a radon refresher for those who weren't able to make it last time, and just to remind us of what radon is. And then he'll dive into legislation. So what do you have to do in terms of testing and mitigating? And then he'll cover those testing and mitigating subjects in a little bit more detail. And as I mentioned, there's an opportunity to get your questions answered. Now, at the end of our last webinar, we had so many questions, we were not able to get to them all. And there was one question that Bruce just wanted to follow up here now. So I'll give you an opportunity to do that, Bruce, and then I'll sort of introduce you a little bit more formally.
Yeah, thank you, Naomi. And by any means, if we didn't get to answer your question, feel free to contact me. I'm happy to talk about radon. But one of the key questions that someone, and actually more than one person came up with, was if you have a large building portfolio and a number of sites, is there a way to prioritize those sites? And that is definitely something we would do. We have a large database and know all the pre-existing studies that have been done. So we can take your site locations and split them up into, for lack of a better term, high, medium, and low risk, so that you can spread your testing out over a number of years and manage your health and safety budget wisely. So that's done quite often. We can help you with that for sure.
Awesome. Thanks, Bruce. So just to introduce Bruce a little better, Bruce has over 15 years of experience in specifically radon in Canada. And he is a member of the board of directors for the Canadian Association of Radon Scientists and Technologists, or CARST. He has presented to a variety of organizations across Canada on the topic of radon associations such as Toronto Construction Association, the City of Hamilton, the Ontario Building Envelope Council, and many others. Bruce is passionate about radon, and he is a self-professed radon geek. You'll find that out today. And he is committed to remaining at the forefront of regulatory updates, emerging technologies, and being involved in cross-Canada radon studies. So you're really in good hands when we say you are talking or listening to a radon expert today. Bruce is a registered assessor for radon under the Canadian National Radon Proficiency Program, or C-NRPP. He brings to us an incomparable wealth of knowledge and experience. So without further ado, I'd like to hand the webinar over to Bruce, talking about radon regulations and your responsibilities. Thank you,
Thanks,
Bruce.
thanks, Naomi. Thanks for everyone for making it today. And if you're back for session 2, thank you even more. And if you missed session 1, don't worry, we'll give a very quick summary of what happened before, so you're not starting from zero. Anyone here who's familiar with ECHO? I'm new to ECHO, but not new to the industry. For the last 7 years, all I've done is test radon nationally across Canada and fix buildings, commercial buildings for radon. So I have a lot of experience, and hopefully I can give that to you. But please feel free to ask any questions or contact me later. I'm more than happy to answer them. So if you missed radon, episode 101, what is radon? Simple. It's radiation, causes lung cancer. It's in every building. And as an employer, you need to measure those radon levels in the building. And if they are elevated, you need to control worker exposure to radon to reduce the risk of lung cancer. Leading cause of lung cancer in non-smokers, and kills over 3,000 Canadians a year. So it's significant. Its cancer risk is about 10,000 times that of asbestos. If you're familiar with buildings, you're familiar with the legislation and the details we have to go through with asbestos. It's not that the radon is 10,000 times more toxic. It's the fact that everybody's exposed all the time. If you're in a building, you're exposed to radon, even at lower levels. And those lower levels do carry a risk, right? Whereas not all buildings have asbestos in it, and those buildings with asbestos in it, it's not always airborne. But estimated by CareX, over 188,000 Canadians are occupationally exposed to radon. So it's a significant thing. Doesn't matter where you are in the country. There's no such thing as radon-free areas. So every workplace has to be tested. And we found, and Health Canada has found, that approximately 4% of commercial buildings, so that's institutional, commercial, and industrial, exceed 200 becquerels, right? And 200 becquerels is the Canadian action level for radon. And that's becquerels per cubic meter of air, and a becquerel is a nuclear disintegration in a second. So 1 tick on a Geiger counter. So imagine 200 ticks in a second in a cubic meter of air. That's the unit we use, if you really wanted to geek out about it. But radon in your workplace, pretty simple. All provinces have some type of general duty clause that requires protecting workers. None of those clauses exclude radon, and they're certainly broad enough to include radon. And for any radon-related illness or lung cancer, they're a compensable claim under occupational health and safety law in Canada. So I get a lot of comments from people saying, yeah, but nowhere in the reg does it say thou shalt test for radon or thou hast to test for radon. Now, the regs say that about a lot of different chemical compounds or things we're exposed to. The mechanism with which radon is enforced in the workplace is exactly the same as how mold growth would be legislated or enforced in the workplace. So it's no different. If you're in a federally regulated workplace, the Canadian Occupational Health and Safety Act is very clear. You can't expose a worker to more than a certain amount of radon. So if you don't know, you haven't tested, you haven't assessed, you haven't complied. And then, of course, we just discussed the territorial and provincial ones. The duty's still there. It's just not as clearly laid out. And virtually every cognizant health and safety agency across Canada has recognized radon as a physical agent, as radiation, and that it is in buildings and they recommend testing, right? So it's kind of hard to get away from it. And the guideline that applies for radiation or radon in the workplace is a guideline called NORM. So it stands for Naturally Occurring Radioactive Material. This is a Health Canada guideline. And it was revised back in 2011, and it specifically covers radon now. They pulled it out because there was some confusion, right? So, but it recommends that all workplaces be assessed for radon, and where the average annual concentration of radon is above the action level, that you take mechanisms to protect the workers. And that can include reducing public or worker access to areas that are high in radon, can change your work practices, like reducing shifts or things of that nature, or reducing the overall radon concentration to below 200. Now, if you've dealt with norm and radiation before in the past, it's rather interesting because all radiation exposures dealt with something called millisieverts per year. So since we're not measuring the radiation directly, we're using radon as a surrogate because if you inhale it, we're using the 200 becquerels as a surrogate to equate dose. And so if you're at 200 becquerels per cubic meter for a 40-hour work week, that's the equivalent of roughly 1 millisievert per year. And that's the maximum dose without starting to get into risks that need to be addressed, okay, or unacceptable risks that need to be addressed. And NORM says that the workplace should be periodically reviewed to make sure conditions and radiation levels haven't changed. This is a super exciting part. I'm going to delve into legislation just a little bit, just for 2 slides, for Ontario and Quebec, because that's where the majority of our participants seem to be from. But generally, it falls under the same thing for just about any province. So in Ontario, general duty clause to 25(2)A, you have to inform and instruct workers and supervisors on how to protect the worker health and safety. And then there's 25(2)H, which is every precaution reasonable under the circumstances to protect a worker. That's pretty broad sweeping, but it's there for a reason because we can't foresee all ends. So those are the clauses that the ministry would use to enforce it. In 2016, the Ministry of Labor identified NORM as the standard by which they would go to. So if you get a complaint you're in Ontario about radon, a worker complaint, the ministry will come and enforce NORM, right? And they would use the general duty clause to invoke that, right? Now, if you go to just general Ontario legislation, it doesn't specify radon exposure controls. So that's where we go to Health Canada. That's where we go to NORM. But if you look at the the Ontario regulation for control of biological and chemical agents, they specifically refer to a CGIH table, which is the American Conference of Governmental Industrial Hygienists, and that's prescribed in the regulation. So those are US criteria that apply to Canada. And if you go back and you look into that table, the dose limit is 1 millisievert per year. So again, just a little conversion if you're looking at numbers and they're not making sense to you. And in WSIB compensation of Ontario, worker that's been injured is, for example, they're entitled to claims or benefits for the impact. The accident also covers disease. And in this case, the Act provides for a presumption of causation for an illness or disease or accident caused by exposure to X-rays, radium, or other radioactive substances. Radon is another radioactive substance, so it applies. And if you're not familiar with the term presumption of causation, basically the courts assume or presume that the lung cancer that the worker has was caused by the workplace, and it's then your duty to prove otherwise. So Quebec, again, has general duty clause, basically respecting occupational health and safety. They have one key portion that says that ventilation shall be adequate to control worker exposure. That's pretty straightforward for most chemicals we deal with, but it could be natural or mechanical. But it's a little different when they get into their radiation issues. They realize that workers that are exposed shall be monitored for dosimetry. So if you don't keep the radon below 200, the worker's been exposed, then your workers technically would be wandering around with dosimeter badges, radiation dosimeter badges. And in the event that a worker is overexposed, they need to undergo medical training, or sorry, medical evaluations. So that's not necessarily where you want to be, right? And in their compensation, basically the same thing. Accident and illness is identified in Quebec as compensable, and they have the same clauses of presumption of causation for radioactive substances. So duties as an employer responsibilities. Your employer responsibilities for exposure to radon are the same to all other workplace hazards. You have a duty to recognize, assess hazards in the workplace, control those hazards, and evaluate those hazards to make sure that your controls are working. So, we do that a lot of times in various other aspects of our job. You're probably very familiar with your facility, but not so familiar with radon. How do we do that with radon? Well, we test all our occupied buildings, because if you don't test, you don't know, right? We follow the Health Canada guidelines to show that we followed a prescribed method of testing and the test results are valid. And if we use certified individuals, then we can demonstrate competence of those individuals and that our testing was done properly. So that's how we would manage our responsibilities and competency. So this is Health Canada's guideline for measurements for radon in workplaces, schools, daycares, hospitals, care facilities, and correctional facilities. So this covers workplace, right? Everything else is deemed residential, but this is, there's residential, but everything else is deemed workplace or public buildings. This guideline would be used if you're in a situation where you're a tenancy situation. So if you had multi-unit residential buildings, like an apartment, this is what you use for testing, right? Because that would be a public building, or you would have workers in there, custodial staff or office staff managing that facility. So that would apply. This document, it establishes and sets out best scientific practice. So measurement duration, what tools and methods to use, the action level, how we measure it, strategy, the location. But what's different with this as opposed to residential is there's some more significant quality control in there. So you have to have duplicate samples every 1 in 10, a blank sample every 1 in 20, and travel blanks, storage blanks, and if you're a lab, spikes. So, if you're a homeowner, you go and get a, do-it-yourself kit, that's, you're going to get reasonable results. But beyond that, this type of QA that's required to make sure that your results are valid and defensible to the Ministry of Labor or your Joint Health and Safety Committee takes a little bit more training and a little bit more understanding. So how do you know that that's being completed and that that level of care has been taken? Well, Canadian National Radon Proficiency Program has been around for a long time, and it certifies radon professionals, it certifies laboratories, and it certifies instrumentation so that you know that the instrumentation, if you're using electronic meters, is acceptable. And so this helps ensure competency. And if you use competent individuals that are certified and all the appropriate certified equipment, you reduce your liability as an owner or an employer. You get more accurate results, or you ensure that results are accurate. And the expertise is well worth what you pay for, because if the samples are done incorrectly, you're waiting another year to test, or you're spending a whole bunch of money that you don't need to test if it had been tested properly, or dealing with a lot of anxiety from workers in the workplace. And that can really reduce overall costs. I've been involved with a lot of situations where improper testing has led to having to do it again. It's always cheaper to do it the first time and to do it right the first time. 3 basic ways Health Canada allows you to test: alpha track detector, which is the most cost-effective method that is typically used. It's quite accurate. Ion chambers, they're great, accurate as well, a little bit more expensive, but I'd say more prone to occupant tampering, intentionally or accidentally. Continuous radon monitors, and when we're talking about these for the purpose of testing a commercial building, we're talking about specifically the professional grade ones. You can go on the internet and get a whole bunch of sort of home-based kits or home-based monitors. There's a large number out there that are actually quite good, but they're not a professional grade monitor to do a workplace. So the ones in the workplace are several $1,000s. So they're beneficial, but quite costly, and doesn't make a lot of sense for your first testing, or if you have lots of buildings across the country. So Alpha Track's probably going to be your first choice. Again, if you weren't around for the first webinar, radon has to be tested over a minimum of 3 months in the heating season, which is roughly October to April. The reason why we do that is radon fluctuates dramatically from hours to days to weeks. And by taking a long test duration, you average out those peaks and valleys and get a very representative exposure of what your radon is, or the radon in the building is. That's important, because if you do a short-term test and you get a false high, then you're spending a whole bunch of money that you don't need to spend necessarily to fix a problem that's not there. But more concerningly, if you test low, you don't do anything and people continue to be exposed, and then your liability is there, and it's even worse because you've done the testing wrong. So what are the action levels? Health Canada sets it at 200 becquerels per cubic meter. I've said that a couple times already. But World Health Organization has a level of 100 to 300 becquerels. And 300 is only in the cases where it's virtually impossible to get the radon levels down. And if you're at 300 or over, in Ontario, following the ACGIH tables, you automatically invoke much more work to ensure workers aren't overexposed. My advice, some clients want to reduce exposure as much as possible, so they've gone to the 100. You can tie your hands that way. My recommendation is test your entire portfolio, find out what buildings are over 200, fix those buildings, and then you know what buildings are over 200. And then if you want to go back and reduce worker exposure, you at least know what buildings need to be done, and you can come up with a realistic approach on how to do that, and do that in a cost-effective manner, right? So that's my personal recommendation. But since this is a cancer-causing agent and we're looking at stochastic effects, probabilistic effects that wind up resulting in cancer, as low as reasonably achievable is the underlying drive. So we want to get radon and radiation exposure down as low as possible. So testing strategies. Basically, you're testing all occupied rooms in the building that contact the ground or are above a crawl space or basement or something of that nature that's not occupied. So generally, this winds up being the lowest occupied level. Might be the basement, might be the ground floor, might actually be the second floor. And we're only sampling rooms that are occupied by an individual more than 4 hours a day, right? So that's not 4 people go into that room for an hour each every day. That would technically be unoccupied. When in doubt, test it, but that's not occupied. So keep that in mind. I've seen lots of unoccupied rooms tested, which causes grief when it comes time to fix the buildings. Again, anxiety and confusion in the workplace, and health and safety money not spent wisely. Okay. And if you've got cubicles, a large open area, you're allowed 1 sample every 200 square meters or 2,000 square feet. That can be treated as 1 room. So the intent is to cover the entire footprint of the building. And hopefully you can see my pointer here. Remember we said all rooms, occupied rooms that contact the ground. Well, remember, ground can contact the wall of a room and not necessarily the floor. So in a building like this, where the two basement levels are occupied, you test every room on the bottom floor, but then every floor up there, you would be testing every perimeter room because the radon can seep in laterally from the soil. So the red dots are places you don't have to test because they're not occupied. If you're in a place where the lowest level isn't occupied, you don't test there, then you go up to the next level, the next lowest level that's occupied to get the whole footprint of the building. And in a few situations, a few cases, particularly large commercial buildings, that might mean that you're testing on the second or the third floor to a certain extent. Okay. In large high rises, you would consider testing the upper floors because remember, radon's sucked in through the ground and the building acts like a chimney. So very often the radon is high on the lower parts, but as it gets sucked up to the top of the building, it dumps radon through elevator shafts, etc., into the upper levels of the building. So you can have high radon on the bottom, nothing in the middle, and high radon on the top. Now, another question that I get quite often is if you're in a commercial building and you're renting a space on the 10th floor, well, people sometimes don't want to test the 10th floor because it's not ground contact. But as an employer, you still have duty to your workers, right? So unless the landlord's giving you some information to say we've tested the building and it's fine, what you would need to do would be to test the floor that you work on. And then if it's high, then go to the landlord and tell them to fix it. So the Health Canada documentation tells us where to deploy a detector. And I'm not going to get into all the details of this because you can easily read that. But the crux of the plan is to place the detector in the breathing zone. So you want the detector to be in the space of the air that the people are breathing, right? Typical industrial hygiene. And you want it to be far enough away from things that can influence the test in a negative way. So there's some criteria there. How far from the floor, how far from the wall, how far from the ceiling. And you don't want it to be on a shelf somewhere or jammed in beside objects where it's going to get covered and the air is not going to move around it. So you want to make sure that the air is, naturally moving around the detector. Okay. Health Canada allows you to hang it from a ceiling or stick it to a wall. My preferred application is sticking it to a wall or sticking it to non-movable furniture because they tend to not go missing when that happens. And you can hang them from the ceiling, but remember, if you've got motion alarms, they'll be dangling and they'll set off the alarms, which typically upset people when they have to get up at 2 a.m. and go and answer the alarm. Where not to test. There's a few places where we don't want to test that makes sense. And again, we're testing the occupied areas, so where people spend 4 hours a day or more. So we don't test the bathroom, we don't test kitchens or storage areas. We wouldn't test underground parking unless there's a security kiosk there or some other type of permanently occupied space down there. We want to keep the detectors away from electrical appliances that could potentially interfere with the test. So computers, stereos, speakers, television sets, that type of thing. And of course, we don't want to put it in a place where it's by a window, or there's a vent or fresh air blowing past it. So we want to keep it away from there because we want to get samples that are representative of the worker's exposure. Okay. So if it's high, what do we do? Well, if it's above 200, it needs to be fixed. It's that simple. If it's below 200, you don't have to do anything. But there's ideally, if it's above 200, Health Canada's new recommendation is fix it. But there are some older recommendations out there that you have about 2 years to fix it if you're between 200 to 600. And if you're above 600, you have 1 year. But if you test over, don't panic. Doesn't have to be shut off tomorrow. There's some time, right? So take your time and do it right. Now, one of the interesting things is, we test for 3 months and the radon detector, the alpha tracks and everything, they test 24/7. So it's important to realize that there's a lot of buildings that have, commercial ventilation control, heating, ventilation, and air conditioning. And those buildings are on a timer or on some kind of automated stat that when the building's not occupied, they turn down the ventilation system because you don't want to be heating and cooling a building if no one's there. You want to save the money, and you want to save the carbon that we're pumping into the environment. So that's a good thing. But what happens is if there's no ventilation or limited ventilation in your building, the radon levels can increase. And your radon detector, your alpha track for the 3 months, will be picking up those highs. So you sometimes get a situation where your long-term test is a little bit over 200. Well, what we can do is we can take continuous radon monitors and we can correct that measurement to account for those times when the radon was high and the radon was low. And in some situations, you can actually use that information and find out that the workers aren't exposed during the daytime hours because the fresh air is being brought in. Okay. So we would use CRMs to do that. There's a whole process. There's some requirements on when it's applicable and when it's not. There's some math. Don't let that scare you. You can come to us. We can help you with that. But ideally, you want to make sure that when you do your follow-up testing, it's the same time of year that you did your original testing, because again, you want it to be representative. Okay, so we can do that. This doesn't happen too often, and typically, if you've got a building that's very high in radon, this wouldn't do much for you. But if you have buildings that are, kind of close to the action level, this can help out. Or if the building doesn't have a robust ventilation system, right? If it's natural ventilation, this won't help you. If it's baseboard heating with not much air, fresh air, this probably won't help you. But this can help, and it can save quite a bit of money. So what are your possible actions? If you test high for radon, you're over 200, you don't sorry, if you're under 200, you don't have to do anything. You're good. Off you go. But if you do test high, you have a few options. You can change or discontinue the use of the building, right? That might not make sense if, in some cases, but if it's a shop, you might want to just turn that into storage. You can mitigate and bring the radon level down, which is what most people wind up doing, or the conclusion they come to. Or you can wind up controlling the worker exposure to norm, right? So that gets involved, and we're going to get into that a little bit, right? So before you get too excited and say, oh, I'm just going to control my worker exposure like I would to any other chemical compound, norm splits it up into 3 categories. Unrestricted, which is less than 200. So you don't have to do anything. Somebody's not overexposed at that point. If you're between 200 and 800 becquerels, that's a dose management requirement under norm. And there's a whole bunch more requirements here than I'm laying out. But you have to notify workers they're being exposed to radiation. You have to train them. And then you either have to estimate or measure their dose and report that annually to the National Dose Registry. If you're a bank branch, you probably don't want to do that for your tellers. It doesn't seem practical, right? If you're above 800 becquerels, which there are commercial buildings out there that have tested over that for sure, you're basically introducing a formal radiation protection program. And that's a lot like working at a nuclear power plant. And you're required to have workers wear and use protective equipment and clothing and procedures. So if you're a restaurant, imagine you're over 800 becquerels and your clientele comes in for dinner and your staff are wandering around with half-face respirators on to filter out the radon daughters. Not going to go over very well. So typically what happens is you wind up gravitating towards mitigating the building. And this is basically just a graphical representation of that same process we talked about. Again, if you're not above 200 becquerels, you're fine. And you only have to retest the building if you make changes to its occupancy or its structure, its ventilation. On the other side, if you're above and you go the norm worker control route, we've touched base on what those are. Those are very, very arduous and very costly programs, right? You can imagine nuclear safety, how intense it is, right? So not practical for most businesses at all, right? The spot in the middle is to mitigate the building, bring it down to less than 200 becquerels, right? And then you only have to retest every 5 years or when you renovate or change the HVAC. So try and stay to the right, not the left. So mitigation. So what do we do if we have high radon? You got options, but the general principle of radon is sealing, depressurizing, and ventilation. It's natural to say, oh, well, we'll just seal it out. I got workers, I got handy people, I've got technicians, they can go around and seal stuff up with a caulking gun, right? Um, Definitely give it a shot, but I pretty much guarantee it's not going to work. Very seldom does that ever work by itself alone, right? We'll get into that in a little bit. Depressurization, instead of and that what happens there is instead of the building sucking the radon in, we put a system underneath the floor slab that keeps the radon from getting sucked in, and we just suck building air down. We can do that with a membrane on an earthen floor, or sometimes we can pressurize the building, okay? Or we can just increase the ventilation. Increasing the ventilation, good and bad. Okay. Why does sealing never work or seldom work? It's too tedious. There's too much detail required. This is what Health Canada stipulates is required in radon sealing and mitigation on how to properly prepare and construct an effective and durable and lasting seal. No one's going to go to this effort. Like we all know that, right? So, and you might not be able to reach everything that needs to be sealed. And you don't need a huge opening to cause a problem. So you need to seal everything. So it's unpractical, it's too tedious, and it virtually never works. We do seal when we do the other mitigations because it makes sense, but don't expect sealing is ever going to solve your problems, okay? Subslab depressurization is the gold standard. It reduces radon on average by 90%, virtually 100% of the time. So this is the golden standard. And you're just basically reversing that pressure so that instead of the soil gas being sucked into the house, you're sucking home home air or building air underneath the slab. Okay. Not that expensive to install and very, very effective. You can also depressurize the sump pit and take advantage of the weeping tile or drainage tile running around the building. Not all buildings have that. Sometimes the weeping tile is on the exterior of the building. You can run a weeping tile around the exterior of the building and depressurize that. There's pros and cons to all of these. Still, the depressurization is the gold standard. But again, it's building construction. Where's the building and where's access and all these other things to consider, right? If we have a earthen crawl space or a crawl space with a dirt floor underneath it, obviously there's no slab to depressurize. So we put a membrane in and we put some suction under that membrane. That membrane is sealed to the wall. Incredibly effective, works just as well as subslab depressurization. And it might be a combination of these things that you use to fix your building. Sometimes the crawl space is so short that you can't get in there and put down the membrane, so you can depressurize the crawl space. One of the challenges with this, though, is remember you're putting some air through that crawl space. You're pulling humid air from the occupied space down. So you have to pay attention to things such as freezing of pipes, foundation heave, moisture and condensation buildups. You don't want them to cause a mold problem. So this does help. It seems quick, it seems easy, but there's a lot of things to consider, right? Another one is building pressurization. Now, technically, a building should be slightly pressurized, right? If it's built correctly. So the intent here is you pump more air into the building than you suck out, right? And that treats the building a little bit like a balloon, just a tiny little balloon pressure inside the building. And then instead of the building being able to suck the radon from the ground, the building air pushes down into the ground. So this can go a long way to stop buildings from being high in radon. But remember, it has to be designed properly. If you're pushing too much humid air from the inside of the building out through the building envelope, you can cause rot and condensation and other things in your walls. So you really need a professional to help you design this. Difficult for high rises, not necessarily applicable for all constructions, but it is another option. And again, sometimes we use these in combination. Each building is different. You have to treat the building as a whole, as a building scientist, and think about it, right? Depends what you're doing in your building too, right? This wouldn't work for, a building that has a lot of humid air in it, for example. We're going to do a couple case studies. These are from my personal experience. This is an older building. It's in southwestern Ontario. It was a two-story block wall foundation, so it had a basement and a main floor. The radon levels were pretty high of initial testing, 345 to 420 becquerels. And what we wound up doing with this one is we had to wind up doing subslab depressurization. So we put suction underneath the floor, but we also had to depressurize the block walls because there's so many cracks, as you can imagine. Block walls are porous. There was a lot of air and soil gas coming through the block walls, contributing to the indoor radon. So we were able to get the radon down to less than 35, right, with a single fan operating at about 600 or 68 liters per second, and not a lot of pressures, 40 to 30 pascals, so very little bit of pressure. So this fan is probably only drawn about 30 watts, so it's like leaving a light bulb on. So not a lot of energy consumption at all. Dilution ventilation, I touched base on this earlier and in the earlier presentation. You can just crank up the ventilation in your building to reduce the radon, whereas dilution is your solution to your pollution. So what that winds up doing is that will work, but you have to have a robust ventilation system that can manage that, a good heating system, a good cooling system that can keep up. Not all buildings have that. And remember, if you want to reduce your radon concentration, if you want to cut it in half, you have to double the amount of fresh air you're bringing in. That's quite a cost for heating and cooling. So a lot more energy costs, a lot of wear and tear on your ventilation systems. So reduce life expectancy of your mechanical systems, more upkeep. Sometimes this works for you though, right? Depends on the building. Treat it as a whole. If your ventilation system can be piloted by an additional stat, you can put in a radostat, which is basically instead of a thermostat, it measures radon, calls for fresh air when the radon gets high, and shuts off to regular operation when the radon levels get lower. So these work. But again, your system has to be able to pilot it, and you have to have a robust enough ventilation system for this to work. But mitigation by ventilation does work. This is a case study of a building in southwestern Alberta built in the 80s. So you'd expect it to be, energy efficient and good without any problem. But it had a poured concrete foundation and a floating slab. And there was a big gap between the slab and the wall. But the basement was all finished. The client didn't want to go and rip the basement apart to try and seal that. And it wasn't really practical under the construction of the building to put in sub-slab. So, and this was the client that picked 100 becquerels as their action level. So on the main floor, it was occupied. The peak was only 160 becquerels. So we really only needed to drop it 60 because the basement wasn't occupied. So a little bit of fresh air might have worked here. So what we did was we were able to get it down to 30 becquerels. And all we did was we increased the rooftop economizer, opened it 5% to let 5% more fresh air come in. And the fan was set to continuous operation. And so that's one where HVAC worked very well without a huge impact on the operation of their system or the life expectancy of their system. Talked about membrane depressurization. Again, this is a case study we did, single story financial institution out in southeastern BC. It had a partial basement and a partial crawl space. And it was interesting because only the rooms above the crawl space were testing over. And it wasn't huge. It was 120 becquerels. But again, this was a client that picked 100 becquerels and then had to follow through with it. So we reduced it to 25 becquerels, and we basically did a subslab depressurization in the actual basement, the full basement, and we put a membrane under the crawl space and depressurized that. Okay. The fan had to work a little harder because the soils were tight. So it had to, put a little bit more vacuum, suck a little bit more to get all the radon from all the corners, but reduced it quite dramatically. But the added benefit of this was the staff, strangely enough, were less worried about the radon. Every time they walked into this building, they would complain that it smelled like a janitor's mop closet, and that was because of the crawl space underneath. The next day when they came in after the system was running, that smell was gone. So the staff were ecstatic about the increase in air quality. And strangely enough, not so much because of the reduced lung cancer risk, but because it smelled better. Okay. So retest requirements. There's a couple retest requirements that you need to be aware of. If you don't exceed the radon action level, you don't need to retest unless you make changes, significant changes to your ventilation system. Kind of obvious, that makes sense. Or if you change the building, do some renovations where you can increase the amount of contact that the building has with the soil, or change the way the ventilation system or the pressures work on the building. My advice is try not to just figure out what those significant changes are. If you do a change, just retest. Or if you change the room occupancy, if you had a bunch of basement rooms that you decided to turn into offices, you've changed the occupancy, now you need to retest it. And for buildings that have been mitigated, you have to retest them every 5 years. Now remember, if you've sealed a building and you've got the radon down, that's still technically mitigated. So you still have to test it every 5 years, right? So you don't have to have one of the other systems every 5 years. If you've gone with the norm controls, the agency, Ministry of Labor that initiated the norm, might require you to test more frequently. So you might have to retest every year. So that's something to keep in mind as well. So in summary, radon's in all buildings. You got to test, because if you don't test, you don't know. If you have high radon, workers need to be protected from radon-induced lung cancer, and you need to control those radon levels. Either reduce it in the building or control the worker exposure. And most buildings can be, remediated very cost effectively. I have not found a building yet that we haven't been able to get below the action level. Here's some resources where you can contact me and find out some more information. And I believe Naomi is going to cut and paste those in the chat, make them available. And now we're to questions.
Wonderful. Thank you so much, Bruce.
And my questions are on my
Appreciate.
other screen here. So everyone, if you check me reading, I'm still engaged.
Yeah, thank you so much for that. I really appreciate your time, and I hope everybody found that information useful. We do have a couple of questions, and if you do have any more, now is the time to ask them. So I'll kick it off with a question from Haitham. The OBC, Ontario Building Code, does it include regulations related to radon? If yes, which part? And I think this is a perfect segue into
Yep.
our next webinar next week. So
Yes, definitely attend webinar number 3. Short answer to that, yes. OBC does include regulations and requirements for radon-resistant new construction. I'm very familiar with that. And it's in Part 9, but it's in Part 6, depending on whether it's commercial or industrial building. The interesting thing is OBC is in January. It is adopting NBC, National Building Code. And National Building Code has some specific requirements for radon as well. So there's going to be some changes coming down the pipe if you're a builder for that. And we'll be covering that in, I'm going to say quasi-nauseating detail in webinar number 3. Great question.
thank you, Haitham. Curtis asked what detector you would recommend for continuous radon monitoring for commercial buildings. And then there's also a link here that Fadi provided for a list of approved devices by C-NRPP. But from a professional experience perspective, Bruce, are there any particular ones you would recommend from there, or are you just kind of?
Well, first of all, thanks, Fadi, for placing that up there. I know Fadi from IPEX. He's been in the radon world for a long time. He's right. That gives you a list of acceptable devices for measuring real time. But if it's a workplace or commercial building, I strongly recommend that you start with the Alpha tracks, and then if there's a problem, go with the higher end CRMs. Because remember, if you've got 50 rooms, you're putting a detector in every room, right? So that would mean if you're trying to measure 50 rooms for 3 months, you need 50 continuous radon monitors. So you're spending like 50 grand for that stuff versus a fraction of that cost for the Alpha tracks. But Airthings makes a great one. Radon Eye makes a good group of them. So Airthings, there's a lot of good ones out there, and I wouldn't say that one's better than the other. They have different options for connectivity to cell phones and Wi-Fi. So it's really whichever one suits your needs, I think is the best answer. Just as long as it's on that C-NRPP approved list, you'll be fine.
Thanks, Bruce, and thanks, Curtis and Fadi, for those questions and answers. We have one here about mitigation being complete. You have to retest every 5 years, as you mentioned in your presentation. Where does this requirement come from?
It comes from a Health Canada document. I can find that for you. It's not directly in the guideline, it's in the mitigation guideline follow-up, right? So
Awesome, thank you. Atif, thanks for your question. The question here is, in what circumstances will the Ministry of Labour or Health Canada request employers or owners to provide radon monitoring data for mitigated buildings? Great question. Thanks, Atif.
Health Canada wouldn't request it. Health Canada simply develops the science. It would be under the Ministry of Labor that would enforce it, and the Ministry of Labor would would require you to test if they got a complaint from a worker or the public. They would come in, they would say, "Where's your radon testing? You don't have it." They would tell you to test. Or if they're in your building during a normal routine or unrequested visit, shall we say, they can order you to do that anytime. So it would come from your local Ministry of Labor, whether that be Workplace BC, Ontario MOL, or whatever.
Awesome. Thank you. Martina asks a question. It's a little bit long here, but I'll read it out for us. So if an employer leases the 12th floor of an office tower, from what you're saying, radon sampling would be required, as that is the first occupied floor above ground level for that particular employer. If the property manager has management offices on the ground floor in the lobby, in which they've completed sampling and the results were less than 200 becquerels, can the employer on the 12th floor use or rely on those results to meet their regulatory obligations, assuming the property manager is willing to disclose their results or report?
Yeah,
Great
I
question,
would
Martina.
say I would be comfortable with that. That depends on you. Remember, you can't contract your duties as an employer, or you're right out from underneath you. So you would have to look at that data and satisfy yourself that, first of all, the landlord tested properly, and that certified people did it, and it was done the right time, the right season. And of course, look at the building and recognize that perhaps the 12th floor is okay. So you assess some risk with that, but that approach could work. Just realize that it doesn't mean you're ironclad and not potentially liable. The ministry would, if in doubt, just make you test that area. So yeah, definitely an option, but testing isn't that expensive necessarily. So sometimes it's easier just to get it done and know. I had a situation where someone in that situation did accept what the landlord had tested, but they tested 2 rooms in the basement. It wasn't a certified professional. They didn't leave the test out long enough, but they still chose to do it. So now they're potentially criminally negligent, I guess, but that's their call.
A little bit of situational
Yeah,
wisdom required there. Yeah.
yeah.
Thanks, Martina, for the question.
Great question.
Sarah, thank you for your question. Sarah asks, do you recommend the same limit of 200 becquerels to all types of buildings? I have a variety of buildings in my portfolio, anywhere from warehouses to childcare centers.
Yes, 200 becquerels is the action limit. It's legal action limit. Again, you're allowed to go lower because as low as reasonably achievable applies. Every time you cut your radon exposure in half, you cut your risk in half. So if it was a daycare situation, you would certainly be legal if you went to 200. If you get a lot of pressure from parents, you might decide to go to 100, but 200 is the defensible legal cutoff in Canada. So that applies nationally.
Awesome. Thanks, Bruce. Curtis has another question here. We're testing our owned portfolio of buildings. Is there a requirement to test our leased portfolio in Saskatchewan? Is this an OHS or NBC requirements or both? Thank you.
NBC, National Building Code, building code just basically tells you how to build buildings compliantly within the law. Building code doesn't touch base on what occupational health and safety is. So there's two splits here. The building code wouldn't apply for you in this. It's an existing building, so you'd be testing in accordance to occupational health and safety law. So if you're the landlord and you're testing it, you own the buildings, and they're your employees, great. go for it. I've had several commercial clients, same thing, financial institutions primarily, that lease a lot of buildings. And again, if they're your employees in a leased building, you as the employer still have the duty to ensure their health and safety, period. You can't get out from underneath that. So test your lease buildings. If you're the landlord, it would depend on what's in your contract as to who's responsible for that, right? But if the occupant or the person in the building is leasing it from you and they can test their own worker exposure, that's fine. But then it would probably still fall on the landlord or the owner of the building to pay for the mitigation. So you get into some interesting contract law on whose duty is there. Um, so that sounds like a fairly complicated question. I hope I've answered it, but Curtis, I'm more than happy to discuss that in more detail if that helps. It's a great question, a little complex depending on the situation.
Thanks, Bruce. Yeah, if that doesn't answer your question, Curtis, feel free to reach out to Bruce, but hopefully that does. We have a question here about requirements for testing low-rise or high-rise condo buildings.
That
And
would be under the that's an interesting one. Canadian Environmental Law Association did do a review. Tenancy law does have requirements in there. It depends on the province you're in. I could answer that question specifically for you. But it's like anything else. You have to have a building that's reasonably safe for the occupant, and that building can't cause illness, right? So, um, yeah, I think that's a very detailed question. I don't have the answer off the top of my head, but I can find it for you. I have read the SELA document, all 300 and some odd pages of it. So I can find that for you. But if you were to test, you'd follow the same guidelines that we talked about here from Health Canada on where and how often to test and locations.
thanks, Bruce. That question was asked by an anonymous attendee, so if you would like to follow up with Bruce, he would be more than happy to give you a bit more detail there.
Absolutely.
The last question we have, and we've got 5 minutes left, so we have time for maybe one or two more if anyone has any additional questions. But the last question from Haitham here, is there a relation between the underground water level and radon levels?
Oh, that's a fantastic question with about 400 answers. Um, yes, groundwater does have effects on radon and how it gets into the building. It takes up pore spaces in the soil that the radon moves through. Um, Trying to use the water level to determine whether a building is or isn't gonna test over radon or decide to test your building because your water level is or isn't high doesn't really come into play. Test the building. The only time water level really becomes an issue is if we're trying to do subslab depressurization and the water's underneath the slab. It's, you're installing a Slurpee straw. So we have to look at some other mechanisms to control it. But the water level by itself, it's not going to be a green check or red X for radon in or not in the building.
Awesome. Thanks, Bruce. Appreciate your time answering those questions. That's all the questions we have in the Q&A. As I mentioned before, if you have any additional questions or would like to get in touch with Bruce, please feel free to reach out to him. It's B Decker, Decker, at echo.ca. And perhaps you'll get that information in the webinar survey as well.
You can find me on LinkedIn as well.
Correct. Yep. We do have one last question. I am going to make this the last question. So any additional questions we can address next time or via email. So some of our buildings in Alberta have been constructed with a radon mitigation pipe, which vents to the roof area in the work area of HVAC technicians. I realize the radon concentration is diluted with fresh air, but do you have any recommendations for making this a safe area? Great question.
That is a great question. I think what you're talking about there is a radon mitigation system's either been put in or that's the rough-in pipe according to building code. The pipe that moves through the work area or the occupied area is a sealed pipe, so it shouldn't be exhausting or leaking anything to your workers. So it should be safe completely. And if the system was installed and mitigated to reduce high radon, after a system's installed, you test right off the bat with a short-term test to make sure the system's working, and you follow up with a long-term test. So based on what you're describing there, I don't believe there would be, you know, any issue with that. And the exhaust location where the radon would be coming out of the pipe would be placed at the appropriate requirements established by Health Canada mitigation requirements or Canadian General Standards Board. So it shouldn't be re-entraining into the building. So I don't foresee any safety issue there. But if you have specific questions with some details, I'm more than happy to answer them. But from what you're describing, I don't think that there's an issue unless I'm missing something. Right?
Yeah, so the way I'm kind of seeing it, you have the pipe coming off into the roof, and then HVAC technicians are working on HVAC materials on the roof.
Okay, thank
Then
you.
you would have
That helps
that.
clarify it.
Yeah,
I can answer that in a little bit more detail. Again, their exposure wouldn't be 24/7. Health Canada and NRC did a study showing that even high levels of radon exhausting at the pipe drop off to background levels roughly within 2 meters from the discharge point. So again, if workers are working at the discharge point, I wouldn't be overly concerned about that. If you are, they can always wear a half-face respirator with P100 filters on it, or you can just shut off the radon system for the amount of time they're up there.
awesome. All right. Thank you so
Thanks
much
for
for all of the
clarifying that
questions.
question,
Yeah,
Naomi.
for sure.
I missed I didn't see the forest for the trees on that one. I apologize.
Yep, absolutely. Whoever asked about the email list for future webinars, if you can just kind of identify yourself somehow, if you can email us at either learning@echo.ca or email Bruce here, we can absolutely include you on that list. We just don't have your information here. So if you could just skip to the last slide here, we are out of time, but I wanted to invite you all back next week for the last radon resistant new construction. So this is the last webinar in our series. Same time, you can use the same link that you used today. You will receive a reminder. And if you could take a couple of minutes at the end of the webinar to complete the survey, we would really appreciate hearing back from you. So thank you so much, everybody, for attending. Have a wonderful Wednesday. We'll see you next week.
Thanks, everyone.